covalent bond, covalent bonding and electron dot structures. Okay. So in this chapter, we are going to see about covalent bonding in molecules, strengths of covalent bonds, polar covalent bonds, electronegativity, comparison of ionic covalent bonds, electron dot structures, how to draw electron dot structures, how to draw radicals. So it's more or less it's about electron dot structures. Okay. And a portion about resonance. Now, see, covalent bonding. Covalent bonding is, what do we mean by covalent bonding? Covalent bonding is when there is a sharing of electrons. Okay.
Yes.
Okay. In ionic bond, what is happening? There is transfer of electrons. Okay. So we have look at how a hydrogen-hydrogen bond is formed in H2 molecule as the simplest example. So when two hydrogen atoms they come close together, electrostatic interactions begin to develop between them. Okay. Now let's see. This is what is happening. Each of the hydrogen atom has one proton and one electron, right?
Yeah.
There's electron cloud. So electron cloud is repelling each other. Okay.
Mm.
Electron cloud. So this is the electron cloud repulsion. Electron cloud. Both the protons are positively charged. They will also repel each other.
Yeah. But then the proton, I mean, the nucleus and the electron cloud of each
The
of them.
other, they will attract, right?
Yeah.
And similarly, so blue are attractive and pink
Yeah.
are repulsive. Got it?
Yeah.
Okay. So this is happening. So overall, what is happening that the elect attractions are greater than the repulsions. So
Mm.
net result is that we have an attractive force and we get to form something which is called a covalent bond. Now here
Sir,
is the this is the energy interaction. Okay.
sir, so electron cloud is like on like what is an electron cloud?
Electron cloud is something where we are invoking the wave nature of the electron, right?
Okay.
Yeah.
Mm.
Okay. Now hydrogen atoms they are too far. See initially, so there is no energy of interaction between them, and this is labeled as 0 point energy. Okay.
Okay.
As they start to come together, attractive forces begin to develop, so energy is getting released, so they are becoming more stable, so energy is going down up, right?
Mm.
Okay. And what happens that there after some time there occurs an energy minima, and the distance which corresponds to this energy minima, that is called the bond length. Okay, this is we are plotting energy versus internuclear distance. So what is happening? The energy is falling, and as we get an energy minima, the distance which corresponds to that, okay, that is
Mm.
called bond length. Okay,
Okay.
got it.
Mm.
So actually, it is something like this. If I remember correctly, I might not, but I'll just give you an example. There's one constant, and let's say this is a repulsive force R12, and this is an attractive force R6, something like this. And we calculate du by dr, energy minima, okay?
Okay.
And the R corresponding to this is called the internuclear distance, and the R corresponding to this minima is called the bond length. Bond
Mm.
length. Got it?
Okay.
That is the actual treatment, mathematical treatment, which we will also see later on, but for the meantime. So I'll just let it go for the meantime. But this is how it is. So there is an energy minima and the distance which is corresponding to that, that we call internuclear distance. So this is, and if they start coming too close to each other, then what is going to happen? Then the
Energy will increase.
yes. See, repulsive forces, Shreyas, they come into picture when they approach very close to each other. Repulsive forces become dominant only when they come very close to each other. So when they become very close to each other, see, and again they have gone beyond positive energy. It means the bonding is no more there, right?
Mm.
Okay. So that is the idea. Okay. And lines between them, they are shown. These are the covalent bonds. Got it?
Yeah.
CC bond length 153 picometer around about, okay.
Hmm.
And this is the atomic radius. So atomic radius, this is how we are defining, okay.
Okay.
Roughly the half of the
Hmm.
molecular radius, okay. So these are the average bond length. It's fairly simple. Strength of covalent bond. So this the strength is how much. The strength will simply be that amount where we are going to just break it, right?
Hmm. So yeah.
That will be strength, right? If I ask somebody what is the strength of this table, the energy required to break a table is the strength of the table, right?
Yeah.
So similarly, when we have high HH bond here like this, okay,
Hmm.
I will just use, when we have this, if we put energy to it 436 kilojoule per mole, then 1 mole of HH will be broken, okay.
Yeah.
And if this much energy is released,
Yeah. They'll.
form a bond, right?
Yeah.
Okay. Great. So this is, so bond dissociation energies are always positive because energy must be supplied to break a bond, right?
Yeah.
So again, these bond dissociation energies are listed and bond length are also this. So you can see as the bond length is increasing, the bond dissociation energy is decreasing, right?
Hmm. Yeah.
Shorter bonds are typically stronger, okay?
Okay.
So bond dissociation energy is inversely proportional to bond length, right?
Yeah.
Again, they have given the bond dissociation energy, average bonding. Now the multiple bond order. Okay. Now, what do we call the bond order? Say here N triple bond and three lines are there, so we'll say N2 molecule has bond order 3. O double bond, we say that O2 molecule has bond order 2. F single bond F, we say F2 molecule has bond order 1. Got it?
Okay.
The number of lines is the bond order. Got it?
Yeah.
See. Now you can see bond length, triple bond. Here it is a double bond, here it is a single bond. Double bond is shorter and stronger. Huh?
Yeah. And
Triple
then.
bond is shorter and stronger.
Okay.
Got it?
Yeah.
Because the bond order means more bonds are there. So obviously it will be stronger, right?
Hmm.
Makes sense.
Yes.
Polar covalent bonds, electronegativity. So polar means polarity is there. See, this is the continuum. Initially we have non-polar covalent bond, electronically symmetrical. Here the electrons are being distributed equally between both the atoms. Got it?
Okay. So this is for like molecules of of
Same, like chlorine and chlorine come
yeah,
and this, okay.
yeah, okay,
Chlorine will bring one electron, it will be bring one electron, they will make a cake, electronic cake, and this cake is distributed symmetrically because both are chief
yeah,
ministers, huh?
yeah, both of
Both
them,
are same.
yeah,
Now here, what has happened? X is the prime minister.
mm,
Okay.
yeah,
Y is the chief minister, X is the prime minister. They make a cake. So who will eat the larger portion of the cake?
the prime minister.
The prime minister will eat the larger portion. See, it is shifted toward the prime minister if you look carefully.
Oh,
Huh? The dots are shifted more towards the prime minister. Huh?
yeah,
So both have brought 1 1, but X now prime minister is keeping 1.5, right?
yeah,
And it is giving chief minister only 0.5. So it has become delta minus because it has acquired slightly more, huh? Not fully, slightly, right?
okay.
Got it?
So what's like an example of it?
Example will just come, but for the now you can see HCl. Okay.
Okay,
We'll just see it. Okay. Don't worry. So HCl is an example. So got it?
Yeah.
And now what is happening here? There is coming sodium. Oh, sodium is coming with 1 electron, and chlorine has 7 electrons. And here what is happening? It is giving its all the electrons. Huh?
Yeah. And then they share it. Yeah.
This is the US president. Huh?
Hmm.
Okay.
Yeah.
It has taken all of it fully.
Hmm.
So it has become full minus, right?
Yeah.
Now the bond is ionic. It is no more a covalent bond because the fully formed ions are formed, right?
Yeah. Okay.
Here the both the bonds they are covalent. Okay. Here they are covalent. Okay. Because sharing is there. But here it is polar covalent. Polarity has come because it has taken more than it gave,
So what
right?
does polarity even mean? Like the
Sorry.
what does polarity even mean? Like the
Polarity means it has taken more. Will just come poles, positive and negative poles. Polarity is from pole. Okay.
okay.
Just wait on. So Cl2, as I said, is a non-polar covalent. Okay, they are both. Okay. HCl is polar covalent bond. Okay. Why? Because chlorine atoms is more electronegative. It attracts electrons toward itself strongly. That is why this polarity is coming. Got it?
Okay.
Okay. And NaCl is fully ionic because it is taking full. Okay.
Hmm. Hmm.
So this is what is happening. So bond polarity, why it is? It is due to the electronegativity difference. Got it?
Okay. Yeah.
And the atoms which are on the right side, they are more electronegative. Got it?
Okay. Yeah.
See, this is the electronegativity. Just see and tell me which are the top four elements in the electronegativity. And what is the electronegativity? See, it increases from left to right. Huh? They have written it.
Yeah. So
And decreases from top to bottom. Huh?
yeah. So fluorine. Yeah.
Decreases from top to bottom. But sometimes see, here it is increasing. Huh?
Hmm.
1 second. Just come on.
Yeah.
Go through it. Tell me the four top. Which are the top four?
So carbon, nitrogen, oxygen, and
No,
fluorine.
most electronegative. Which one is it?
Yes, sir. Fluorine is the most electronegative.
Fluorine.
Then oxygen, then
Then
nitrogen, and Cl and chlorine. Then
yes, fluorine, oxygen, nitrogen, chlorine. Right?
yeah.
Very good. So when we say that this is the electronegative, usually from left to right, when we are coming, the electronegativity is increasing. But for the metals, we are never concerned with the term electronegativity, right? Because metals with which
That
we
time.
are concerned with electropositivity, right?
Yeah.
So basically, but if you see on the right hand side, this more or less holds the electronegativity as we go down, it should
Yeah.
increase or decrease. It should decrease, right? So it is decreasing from boron to aluminum, but it increases slightly from aluminum to gallium, right?
Yeah.
See here,
Yeah. It's very yeah. Yeah.
huh? Right?
Mm.
And what is happening here? Here it is kind of constant here, and then it has increased, huh?
Okay.
Here, if you see
Then somehow from uh,
oxygen, it has
copper
started doing well, huh? From the 18th or the
from
sixth
copper
group.
to zinc, there's a
16 or 6th group, right? Oxygen, sulfur, selenium. It has done well, huh?
yeah.
So electronegativity in these two groups, here it is doing nice. Huh?
Yeah, the highest.
Yeah. Yeah, they are the most electronegative. So here it is the usual order. Okay.
Hmm.
So here are the rules. Yes. If they are the same atoms, then they are non-polar covalent. If the electronegativity difference is greater than 2 units, then it is largely ionic. And if it is less than 2 units, then we call them polar covalent. Okay.
Okay.
So for example, like this.
So can you go up once? Oh,
See,
okay.
the hydrogen electronegativity is 2.1. Okay.
Hmm.
You can take a photograph of this and then because we need it in this question. Next question.
Hmm.
Okay. Done?
Yeah.
You have a periodic table, right?
Yes, sir.
So electronegativity is there. Check.
No, sir, it's not there. No, sir, it's not there.
No problem. No problem. Now worked example 7.1. Okay. So we have to classify if they are polar or non-polar. See, electronegativity difference is 0.5.
Oh, yeah.
2.1. So this is polar covalent and that is polar. Okay.
Hmm.
Less than 0.5, it is non-polar, huh? Mostly. Okay.
Okay.
At least half unit we need. Now you have to do 7.1. Okay. You had your breakfast?
Yes, sir.
What was it today? Dosa or poha?
Idli, sir.
It'll be nice.
Sir, you?
I'm just having a bit of poha.
Hmm.
On Sunday, I have classes from 6:30. I start at 6:30 and they are back to back classes 6:30 to 8:30, 8:30 to 10, 10 to 12,
Till when?
till 10, till 1:30 today.
That's a lot.
You see, I don't want to keep classes on the weekdays because weekdays I want to keep for myself.
Oh, that's yeah.
So I'm working like a labor.
I guess it's like you chill while everyone's doing their.
Yes, yes, exactly. Very, very aptly you have picked it up.
Hmm.
I also don't enjoy going out on Saturdays and Sundays because there's so much crowd, right?
Yeah, lots of traffic, lots of.
Traffic, and I usually call it that prisoners have got their days off.
Mm.
They're just going
So,
to.
how many classes do you have, like totally?
I have not never counted, but see, I have 11 batch, I have 12 batch. Then I do one to one with you. Then I do one to one with this very bright kid in class 12 called Neha. Then I do one to one with one UAE guy.
Mm.
I also do one to one with another class 10 girl, Avika. Then I've started doing one to one with this another class 11 girl, Ritika.
Mm.
Then I have my class 11 batches and then I have my class 12 batches.
Mm.
But they are usually spread out, right? Like I told you, on the weekdays, it's like
Yeah, it's not
I
that.
rarely have classes. I mean, very few classes I have. And that too in the evening I have. That's it.
Yeah, no, it's a pretty smart strategy when you're living in Bangalore.
Yeah, yeah. In Bangalore, I mean, Bangalore is very, very dangerous, man, in terms of traffic.
Mm.
I'll just keep it.
Sir, can I see like uh
Of
the
course, of course, of course. How else? Nobody's asking you to remember, at least now.
thing is wrong with my keyboard?
One second. I will take my medicine basically. Yeah, you're done?
No, sir. 1 minute.
Yeah, I mean, it's like, I just don't want to be unwell, man. It's like the worst thing you can have.
Sir, first one is polar covalent. Uh,
Okay.
and then the second one is ionic. Uh, so then the next one is also polar, and then the last one is uh, also polar. No, no, it's covalent.
Yeah, it's non-polar covalent. Okay, there are no poles getting developed, right?
Because
Yeah, you understood now? Got it?
yeah,
So this is electrostatic potential map where we show the negative charge built up by red and the positive charge built up by blue. So tell us where the region is electron rich and where it is electron poor. For example, here they have shown. So red is electron rich. So this is the chlorine end,
yeah.
and this is the hydrogen end, okay? Because it is positive. Got it? Red is negative. So here, do this question now. 7 point. Okay.
Yes,
Yeah.
sir. It's polar covalent.
Now compare ionic and covalent compounds. Okay. NaCl and HCl. Okay.
Okay.
Now see, just go through this and have the what do you call a wow moment. Wow.
Sir, Na is not at all that electronegative. So
Na is not see first see the idea is that NaCl is an ionic compound, right?
yeah. So
And
yeah.
this is a polar covalent compound, right?
So their properties are extremely different.
Right? Ionic compounds are the result of electrostatic attractions, right? Ions, right?
Yeah.
Extremely strong. That is why they are solid. And just look at HCl, huh? What is it?
Hmm. It's it's covalent. So,
Right? And it's a gas. It
hmm.
means that the forces between the molecules are not very strong at all, right?
Yeah. So and the melting and boiling points are very low.
Right?
Yeah.
Okay.
Yeah. It's interesting.
Got it?
Yeah.
So this, let's go through this. See, I employ several modes of instruction sometimes, depending upon the students. Sometimes I employ this, like I ask the student to see what this is. It's like in Mahabharata, Dronacharya is teaching. So he's never teaching in the active manner. He's always teaching in the passive manner. He's asking his students, what do you see? Okay. So the Yudhishthira is saying, I'm seeing the trees, I'm seeing the birds and this and that. Then everybody is seeing things. And the Arjunan says that I'm seeing only the eye of the bird.
Mm.
And he is able to hit. So similarly, you have to see, okay? Learn to see what is happening here. Okay.
I guess the teacher shows us where to look, but then we have to figure out what to look
Of
at.
course, of course, of course. It's just like, you can take a donkey to the lake, but you cannot drink the water.
Mm.
Something like that.
Yes, sir.
So again, we talked about the lattice energy for the ionic crystals, right?
Mm.
So whenever we have Na plus NCl in the Born-Haber cycle, right? Don't worry, we'll revisit it again. So that is the idea. So there we have Na plus NCl. There's a vast three-dimensional network of ions in which Na plus is attracted by many Cl minus ions and Cl minus is attracted by many surrounding Na plus ions. So to melt or boil sodium chloride, all the ions must be separated from one another. This means that every ionic interaction in the entire crystal, which we call lattice energy, must be overcome. A process that requires a large amount of energy. Covalent compounds, by contrast, they are low melting solids, liquids, or even gaseous. A sample of covalent compounds such as hydrogen chloride consists of discrete HCl molecules.
Mm.
Now, in order to melt or boil a covalent compound, forces between molecules must be broken. Okay, forces between molecules, that is intermolecular forces. Okay, in covalent compounds, bonds exist within molecules but not between molecules. Okay,
Yeah.
so attractive forces between molecules do exist and they are called intermolecular forces. Interschools between two schools, intermolecule between two molecules. Intermolecular forces are much weaker forces as compared to ionic or covalent bonds, and therefore relatively little energy is required to overcome them to melt or boil the substance. Okay. Okay.
Mm.
Intermolecular forces, whenever they are they are just the forces between two molecules. Okay. We'll again come into this when we start organic. We'll just delve deeply into them. Don't worry. Maybe in
One,
this chapter. Sorry.
one, 1 minute. I'll just be back.
Yes, yes, yes.
Yes, sir.
Okay. So we have to draw the electron dot structures. The octet rule. Octet rule says that when atoms they form a bond, they share electrons so that they complete valence shell or they attain noble gas configuration or 8 electrons. Okay. Except hydrogen, which needs only 2 electrons to attain the noble gas. Okay.
Okay.
Because helium has 1s2, right?
Yeah.
So now each hydrogen has essentially 2 electrons, so it's like 1s2, right?
Mm.
See fluorine, it has now 8 valence electrons, okay?
Okay.
So similarly, group 3A, group 4A, see? Huh?
Mm.
Sharing. Got it?
Yeah. So
Here, the octet is not complete, but BH3 is more complicated than suggested here. We'll take it up later. Huh?
okay. Then, uh,
Mhm.
I think they did this at school also, like with the dots and crosses instead of the.
Yes, 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 yes.
Mm.
Right? Same thing. Cross this show for the other element. So, but electrons they are essentially indistinguishable. So yeah, got it. See, go through it. Neon will not form anything, right? Because
Well, yes.
it's not interested. Huh?
Okay, sir.
Okay. So you should remember the groups and their elements. So group 3A has 3 valence electrons, 4A has 4, 5A has 5, 6A 6, 7A 7, 8A 8, right? Okay.
Yeah.
Take a while, don't worry. Okay, now I'll show you how to draw the Lewis structures. Okay, I'll just add one page here and I'll. Okay. See, first step is count total number of valence electrons. Okay,
Mm.
valence electrons. So valence electrons will come from group number, right?
Yeah.
Draw basic framework. I'll tell you what it is. And assign remaining electrons starting from outermost atoms. Third is if octet is not complete, if octet of an atom is not complete, we draw a double bond by taking
This in the beginning.
two electrons. Yes, by taking two electrons from adjacent atom. I'll give you an example and it will be clear. And then we calculate formal charge on each atom. Formal charge is given by valence electrons minus lines plus dots. Okay.
Okay.
So now we take an example. I'll take an example of CO2. So carbon has 4 valence electrons. Oxygen has 6 valence electrons. Total valence is 4 plus 2 into 6. 16, right? Okay? Yeah? Sure?
Yes, sir.
Basic framework means we draw the first atom and connect the other atom by single line. Okay?
Okay.
Then one line means 2 electrons, right?
Mm. Just 2 electrons.
So we have used 4 electrons, right? Remaining is 12 electrons, right?
Yeah.
So I start assigning them starting from oxygen. Oxygen needs 6 to complete its octet, right?
Yeah, and then another 6.
Then another 6. Now we are done with electrons. We don't have any more electrons left. But if we see then what is happening here? The what is not complete?
It's complete. No.
Octet is not complete for carbon, right? Carbon only has 4 electrons, right? Yes?
Yes. So
We take 2 electrons from the left carbon and make a double bond here. Okay? Like this. Now this oxygen has only 4 left. See,
but it's still on the bench.
it's still not complete. So we take from the right 2 electrons.
Yeah. So it's 4 on each.
And we are done. Okay? Got it?
Hmm.
Now, this was the third step. Huh?
Hmm.
And final step is where we calculate the formal charge on each atom. Got it?
Okay.
Formal charge is equal to valence electrons minus lines plus dots, right? So formal charge, valence electron 6, lines 2, dots 4, 0, no charge. Similarly, 6 minus 2 plus 4, 0, no formal charge. 4 valence electrons, 4 lines, 0 dots, no formal charge. No charge on any atom. CO2 is a neutral molecule like this. Got it?
Okay.
I'll give you one more example. CO3, 2 minus. So here carbon has 4 electrons. There are 3 oxygen, each oxygen has 6. 2 negative means 2 excess electrons, right? Yes?
Yes.
24. This is the first step. In the second step, we draw a basic framework. 24 minus 6, 18 are only remaining, right?
Yes. So then we add 6 to each carbon.
Oxygen. Okay?
Yeah, and then we.
Octet is not complete.
Yeah.
Right?
Yeah, from one of them.
Final step.
Yeah, formal.
Formal charge. Valence electron 6, lines 1, dot 6, minus 1. When there is minus 1, we just put a minus here.
Hmm.
6 minus 1 line, 6 dots, minus 1.
And then
2 lines, 4 dots, neutral. We leave it like this.
carbon
4
0.
valence electron, 4 lines, 0 dots. 0, nothing here. So see, overall charge is minus 2, huh?
Yeah. So the
Hi. Huh? Cool, huh?
yeah, cool.
Okay. Great. Now it is the champion's turn, huh? To draw. We'll give you some molecules. You have to draw.
Sir, all of them.
Yes, sir. All of them. More or less. Yeah, more or less. Okay. Yeah. Give me 5 minutes, I'll just use the washroom. You know the protocol, right?
Yes, there's a lot.
Don't wait on me. See, this is everything, okay? This is for organic chemistry, for inorganic chemistry, this is everything. It's like locating each atom's, actual position, how many electrons it have, how many, what is the charge on it, right? Because the bonds will be formed by the electrons. So we need to know which atom has how many, okay? It's just like you need to know the precise notes and duration. It's just like that.
Yeah. Sir, the third last one, Cn, is that Cn minus or just Cn?
Cn minus.
Sir, I sent all of them.
Okay. See, when you are writing the formal charges, you have to indicate over the atoms, okay?
Okay, sir.
Okay. Look good pretty much. Okay, I'll draw and then you can also check. NO3 minus will be like this.
Yes, sir, it took a while for me.
NO3 minus, when I recruit faculty, I ask them to draw, and most of them are not able to draw. Okay. NO2 minus. NO2 plus. O3. I'll just, okay, I'll just draw here. CO.
Hmm.
H3O plus. NH4 plus. N3 minus. ALH4 minus. BF4 minus. CN minus. It is like this, huh?
Hmm.
CCl4. Okay.
Okay.
CH3 minus. I think you got almost all of them correctly. Check.
Yes, sir, I think so.
Yeah. Do this. 7.3, 7.
Sir, but in like the electron dot structures that they ask us to draw in school, they don't really put the lines.
Yeah, yeah. They are dumbasses. They want to confuse the students for as long as they can, you know. That is the aim for of the education system.
Hmm.
So that they don't learn anything for as long as it is possible. And it is so cool, right? When you draw lines, right? It's clear that there's one bond between them, right? In class 10, you can show the way they are asking. It's very easy, right? Whenever there's one line, one dot, one cross, you do and make the sharing. Huh?
Yes, sir. Yes, I sent it.
Hmm. Great. There is a procedure. You don't need to look at this procedure. I've already given you one procedure, right? That is more than sufficient. Okay. So this is just like OF2 you have to draw. Now try these. Huh?
Okay.
Sometimes for xenon and everything, they will have 8 electrons around them. So you can just go through. Sometimes the octet is like expanded. Huh? Okay.
Sir, but that won't even form a compound, right?
See, SF4. Okay. Here the octet rule is there, but see, finally, this is the step. So you can see that sulfur has how many? 10 electrons, right?
Oh, so it's an exception.
No, it's not an exception. What happens is that as we go down, like in the sulfur and chlorine, etc., what is happening is that we have d orbitals available, so they can expand their octet. Okay,
Okay.
so we just do the same thing. We just distribute the electrons. Okay, as we have them. Okay,
Mm.
no need to worry. you'll be able to do. Try and then we'll see. Here you will have kind of expanded octet, but draw where at least the other atoms, the group 2, they are following the octet rule. Okay.
Oh. Sir, for the second one, what are you supposed to do about AL's complete?
AL is not getting completed. Okay. AL will remain with 6. Okay.
Okay. Sir, XeOF won't be a compound really, right?
Oh, it is a compound.
Sure, but how will a noble gas react with it?
Oh, there are many things. Okay. They react with extremely reactive compounds. As you can see, only oxygen and fluorine are there, right? Fluorine is one of the most reactive elements.
Hmm.
Okay. And only very lately these compounds have come, yeah. But yeah, they do.
Hmm. Yes, sir. I have sent.
Okay. Nice. Do this one.
Okay. One second, I'll use the washroom.
Sure.
Sir, I think the answer is B. Right?
Okay. Nice. And why?
Sir, because uh, uh, phosphorus has a complete shell, and so do the rest of them. Hello?
Which one you are saying are the correct? B, right?
Yes, sir.
Okay. And why?
Sir, because phosphorus has a complete, um, you know,
Octet.
a configuration.
Uh, what is wrong with the incorrect ones?
Yeah, A is fine, I think, but
Just look at this oxygen. It has made four bonds. It can never do that, right?
yeah.
Okay. We have done for these already.
Mm.
For radicals, we do the same thing. Radicals means something which has unpaired electrons. Okay.
Yeah.
The same thing goes on. We distribute the electrons.
Okay.
Now just go through this and try to do 7.9.
Sir, isn't it the same way?
It is.
Marks. Yes, sir. I've sent the.
Nice. Which species do you predict to be most reactive? Ozone, O3, O2, O2 minus.
Sir, I don't know.
O2 minus, it is charged.
Hmm.
Okay. Then you have to, for group 2, for carbon containing compound, only carbon and hydrogen. We draw it this in the same manner. Huh? Just try to draw C2H2 following our rules and then we'll see.
Yes, sir. It's just H C triple bond C H.
Yeah. And now 7.1.
Sir, how do you do it first? Like, how does the arrangement look like of like CH?
Well, carbon is attached to nitrogen and then distribute the hydrogen. First satisfy the carbon, how many it needs, and then give the remaining to nitrogen.
So is this what the first one looks like? So I sent it.
Okay. Okay, we'll stop now also
Okay, sir.
and we'll start. Yeah, this is correct. Okay.
Hmm.
No worries. Chalo. Okay, bye.
Okay, sir. Thank you, sir.
Bye. हेलो।
हेलो सर।
हाँ भाई, कुछ काम किया?
सर मेरा एग्जाम है आज सो कुछ नहीं किया।
अच्छा, किस चीज का एग्जाम है?
एलन का।
ओके।